Other lecture, we have discussed about market basket analysis. This is an example of association learning. In this video, we'll be learning about another association learning technique, what we call collaborative filtering. Okay. So you might have heard about the recommender systems. For example, if you go to Amazon, you will see that the system is actually recommending you something based on your previous purchase behavior. Likewise, if you are watching some videos on YouTube, then you will also get some recommendation by the system. Okay, these are examples of recommender systems. So we'll be learning about one popular recommender system, what we call collaborative filtering. Okay, so the idea is quite simple. So we actually estimate some sort of similarity between users by looking at their previous behavior. Okay, for example, these two users they actually read similar kind of books, and let's say there is a new book arrived in the market, and she actually preferred to read this book. Okay, so because these two users, they have similar reading preferences, so you can actually recommend this book to this user. So this is the general idea. Okay, the same applies to movie ratings or watching movies. So for example, if these two clients or users, they have similar movie preferences, if she is watching a new movie, then you can actually recommend this movie to this person as well. Okay, so that's the general idea of a recommender system. Now the question is, how do we do that? Okay, so there is a popular algorithm, what you call collaborative filtering. How does this method work? So basically, this is a matrix factorization method. Okay, so we have one matrix that we record all the items that the users have tested. For example, in this case, the first user watched movie 4 and rated it as 5. Okay, the second user watched movie item 2 and rated it as 5. Okay, and you can read through this way. So we have m number of users, and you can quickly see that you have n number of items, in this case movies. Okay, if you pay attention, this matrix is a quite sparse matrix. How do we know? Because let's say we are talking about movies, and we don't expect an user will watch, let's say, 10,000 movies, but there are thousands of movies available today. Okay, and we have millions users worldwide, right? So you can see that if we place all the users in the world as our rows in a table, and then the column as the movies, then you quickly understand that this matrix is going to be a very sparse matrix. Okay, so how do we factor this matrix? Your first matrix, what we call user matrix, will have m entities, just like you have m users in your utility matrix. So we call this matrix as utility matrix. In the user matrix, you will have m records, and then k is your dimension that you want to factor into and define the users. Okay, so in this case, you can notice that the columns are of 2 size, so k is actually 2. Okay, so you are actually defining users through 2-dimensional vectors. Okay, if you do that, then your items will be 2 times n, or k times n. Okay, right? It's a very simple method. So you are actually factoring this m in times n matrix into m times k user matrix and k times n item matrix. Okay, initially you are factoring utility matrix of size m times n into m times k user matrix and k times n item matrix. For example, if you have 8 times 4, your utility matrix, then you will have 8 times 2 if you want your user matrix to be of 2 dimension. You will have your item matrix to be of 2 times 4 dimension. Okay. So what is the optimization process here? Okay. Here we were actually transforming our utility matrix into a user and a item matrix. So the optimization works as follows. Okay, so your model parameters are actually 2 matrices, the user and then item matrix. Okay, so you can actually start with some random values for your user matrix and item matrix, and you try to recreate your utility matrix. Okay, so If you have some values here and some values here, and if you do a dot product, you will get all the values filled in. If you pay attention, only the non-sparse cells are actually important. Okay, we don't need to consider those values that are empty, right? So you just rely on the values that have some real values. Okay, so what we are saying that, okay, I start with some values and then I reproject those on this utility matrix and then try to see that how close I go to the actual values. Okay, so here again you can use any optimization techniques like least square fitting, or you can also do gradient descent, right? The whole idea is that you start with some values here and you try to come close to the existing or available values, okay, using any known optimization method. Okay, so that is the general idea. Now, how do you assign the new coming movies to users? Okay, so here, for example, we have one new movie. The first user actually watched this movie and rated it as 4. Okay, another user, the 7th user, rated it as 2. Okay, so if you pay attention here, what happens that we added a new column where we only have 2 values filled in, and then the rest are actually kind of null values. We don't know like how user 2 is going to rate this movie. Okay, so as soon as you add a new column here, because you have a new item, so you can also add a new column here that will be your new item, and start with some random values here and project back. Then what will happen? All these values will change, right? Again, you have to solve an optimization problem that actually takes these new values with some old values and get closer to all these values available. Okay, so if you do that, then what will happen? When you actually go to the optimal point, you'll have some values right here. For example, if you have values 1.5 and 2.9, you have to get a dot product, so you will get values for these question mark cells, right? So imagine that you got a value here, 4. That means you need to actually recommend this movie to the second user, right? And for example, here, if you have a value, let's say 1, most likely this user is not going to watch this movie. Okay, so that's the general idea. So what's happening? We are trying to factorize a utility matrix into 2 matrices, user and item matrix, through some optimization technique. And once we have a new item, we are actually trying to get those to the values for those users that are unknown by using the values some of the users actually rated already. Okay, so that's the general idea.